First, we are going to the introduction. Computers and communication system process and transmit information through signal, which can represent data, speech, sound, document, and visual image. The signal are created, transmitted, and proceed using moving electrons or photons. The materials involved in the process are classified as electronic and photonic. Some materials known as optoelectronic can bridge both classes and interact with both electrons and photons. Photonic materials consist of compound semiconductor for light emission or detection, elemental dopants for photonic performance control, metal or diamond film heat sinks, metallized films for contact and physical barriers, and silica glass, ceramics, and rare earth for optical fibers. The constant evolution of computer and telecommunication technologies has driven the continuous development of material to meet the increasing demands for faster processing speeds, larger storage capacities, and enhanced connectivity. Through ongoing research and innovation, new materials are being discovered, engineered, and integrated into cutting-edge devices and systems. In this discussion, we will explore the diverse range of materials used in the field of computers and telecommunication, the material properties, characteristics, and their application materials.
Assalamualaikum warahmatullahi taala wabarakatuh. My name is Abdul Majid bin Abdul Rahim, and I will present about material chosen. So the material chosen, first of all, two material was chosen, which is nanoparticles and graphene. Comparing these two material with three aspects: cost, tunability, and flexibility. From the table, we can see that nanoparticle is a low cost compared to the graphene because it determined by the process employed, the purity of the material, and the amount required for the manufacturing process of nanoparticle. For the tunability, nanoparticle have a high surface area to volume ratio, and graphene has a low surface area. For the flexibility, nanoparticles can be even more flexible and employed in systems that require a high degree of flexibility, such as wearable electronics. Graphene highly flexible and can be bent or twisted without breaking. So, from these three aspects, nanoparticles provide a cost-effective, tunable, flexible choice for electronic equipment used in telecommunication, while graphene possesses unique features that make it appealing for specific applications, such as antennas and transistors. Nanoparticles, due to their flexibility and tunability, may be more suitable for a broader range of applications.
My name is Izzuddin. I will explain more about physical properties. The material that we use is a nanoparticle. Nanoparticle has small size, low melting point, high mechanical strength, large fraction of surface atom, large surface of energy. Also, nanoparticles have unique physical and chemical characteristics. For example, the electrical, optical, and chemical characteristics could be considered dissimilar from those of each component in the bulk. In comparison to the bigger size, material behaves significantly different at the nanoscale, and it is exceed challenging to anticipate the physical and chemical characteristics of such a tiny particle. Different ways exist for nanoparticles to interact with one another, depends on the contact force between them. They can either stay separate or form a group. As an aerosol primarily solid or liquid phase in the air, a suspension mainly solid in liquid, or an emulsion to liquid phase, nanoparticle can be formed. The surface and interfacial properties may change when chemical agents are present. through the preservation of particle charge and modification of the particle outer layer, the chemical can indirectly stabilize against coagulation of aggregation. It is necessary to predict extremely complicated composition, possibly containing complex mix of adsorbents. Depends on the growth history and lifetime of nanoparticles. Due to their adaptability, nanoparticles are often employed in a variety of scientific domains. They may be described as minuscule particles with a size range of 1 to 100 nanometer, and due to their size possess a set of quantum properties unlike bulk material. Individual spherical nanoparticles would be considered zero dimension, where nanowire, nanotube, and nanobuds are regarded as a one dimension.
Assalamualaikum warahmatullahi wabarakatuh. I'm Ronito Pasaribu and I'm here to explain about mechanical properties and microscopic characteristics nanoparticle. So in this slide, I put two tables, and table 1 about mechanical properties of metal nanoparticle and table 2 about microstructure of metal nanoparticle. So we move to table 1. There are sample figure hardness, fracture toughness, fracture strength, ultimate tensile strength, and impact strength. For example, sample 1, monolithic AI203 have figure hardness 17.8 GPa and have fracture toughness 3.6 plus minus 0.3 MPa and have fracture strength 536 plus minus 35 and now have ultimate tensile strength and now have impact strength. So we move to table 2. Table 2, there are type of material, microstructure, and description. Type of material, we choose metal nanoparticle, and microstructure, I just put a figure about metal nanoparticles, and description about metal nanoparticle is higher fracture toughness and higher fracture strength. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh. My name is Muhammad Al-Hazim bin Hisamuddin. My student ID is 2020859854. Today I will present about the fabrication method and also the application for the nanoparticle. So I will start first the fabrication method. So basically in fabrication method we have two methods, which is the physical method and also the chemical method. So in each method they have two types of approach, which is the top down approach and also bottom up approach. So basically in these two approach they have their specific method. So the meaning of the top down is the fundamental concept behind top-down method came from the manufacture techniques. And also for the bottom up, usually they use gas phase method and also liquid phase method. So with two phase they have combined in this approach. So basically in fabrication method we have used four type of method, which is the lithography, dry etching, chemical etching, and also ball milling. This is the illustration for each method. So basically lithography is transmit a mask to receive substance picture. Next, the dry etching is the procedure to eliminate the mask pattern from semiconductor material, and the chemical etching is process module that quite significant, which is they also use the masking substance, and then it will etch into the substance. And lastly, the ball milling. So the ball milling is a process from grinding nanotube into very tiny particle. So basically this is the illustration that I said before. So we move on to the next method, which is bottom up approach. So basically in this in this approach, we have four types of method, which is the plasma etching, chemical vapor deposition, Sol-Gen synthesis, and also the molecule self-assembly. So basically, in this approach, they, like I say, they use gas phase and also the liquid phase. So for the plasma arching, they employ a plasma and ion gas in this technique. So this is the illustration. Next, the chemical vapor deposition, the process through which vapor phase chemical are condensed to produce solid phase material. So next, sol gel synthesis. So basically, this procedure to create a different nanostructure. So basically, it like composite material. So they combine some material with another material to make a new material. And lastly, molecular self-assembly. So basically, this method is more like to combine. Maybe we can relate with DNA, the chromosome, so they can spread and also can independently become a new chromosome. So the explanation for this method is spontaneous assembly of molecules into variously sized and shaped nano architecture using a variety of non-covalent interaction. But maybe I can edit some information that there are a lot of method can be related with the top down and also the bottom up. So maybe with another material, we have the another approach to make the product can be changed and can be a new product. So lastly, the application for the nanoparticle. So basically, I will highlight about three type of application, which is the electronic and IT, medical and health application, and also energy application. So basically, in the electronic IT application, we can use some example like transistor. So basically, transistor is the best switch that enable all modern computers. So basically, with the nanoparticle, they can make a lot of things. So next, the medical health application. One of the material, which is the adapted gold nanoparticle, it used to probe for the detection of target sequence of nucleic acid. So lastly, energy application. So it improved the efficiency of raw material through better. So that's all from me. Thank you.
Finally, we're talking about conclusion. Enhanced optical properties of nanoparticles, such as quantum dots, enable precise control over light emission and can be utilized in advanced displays and optical sensors. Signals amplification properties of metallic nanoparticles, like gold or silver nanoparticles, can boost the performance of optical communication systems, leading to improved signal transmission and reception. Nanoparticles, particularly magnetic nanoparticles, hold promise for high-density data storage, potentially revolutionizing the storage capacity and retrieval speed of telecommunication devices. Nanoparticles can be incorporated into flexible and lightweight materials, facilitating the development of wearable technology, flexible antennas, and portable communication devices. To fully harness the potential of nanoparticles in electronic and telecommunication, further research and development efforts are recommended. These include nanoparticle synthesis and characterization, integration into device fabrication processes, optimization of nanoparticle properties, and establishing standards for their safe and responsible use. By embracing nanoparticle technology, we can unlock new possibilities for faster data transmission, improved signal quality, higher data storage capacity, and more efficient telecommunication system. Continued exploration and investment in nanoparticle research will contribute to advancing the capabilities and performance of electronic and telecommunication devices, shaping the future of these industries.